Alright, so in the last video, you did a chi-squared test of independence. And you did it by hand. You were given the observed values, you found totals, then you used the formula to find the expected values, and then after you found that entire new table of expected values, then you went to the observed minus the expected value squared in the corresponding rows and divided by the expected value in the corresponding row to get your test value. And that problem took lots of time to get through. There were a lot of chances for you to make a calculation mistake. And it really, at this level, it is good to see how the problem is done. But our real key here is to get beyond the arithmetic of doing the problem and get to the analysis of the problem in a more expedient way. So we're going to do that very long problem from the last video on our calculator. But it requires us to know how to use a matrix. Now, the first thing I want to set up is I want you to, first of all, do not watch this video unless you've watched the chi-square video where we did the test of independence by hand. So please go back and watch that first. And so let's get started on this one, though. If we really want to just get to the direct how to do it, we first of all, we can let the calculator do the work by understanding that there is a matrix function on the calculator. And the calculator matrix function on most of the TI calculators are if you hit the second button and then above this key, x to the -1 power, which I call the inverse of x key. This is the inverse. The -1 exponent stands for inverse, so this is where you see the word matrix. If you have very old calculators, there might even be a matrix button, but I hope you don't, since those really old calculators don't have enough functionality for a lot of the tests that we're going to be doing in this course. So if we do this, we get to our matrix menu. And I want to show you what that looks like on my calculator. Okay, so if I click get to a nice clear screen, and then click second, and then there's that inverse key, and right above the inverse is the word matrix there. You can see how the second key is color coded with that. So if you click there, we've got names of matrices, and then we have math we can do with matrices, and then we have ways to edit the matrix. Now, this is where we're going to be going to. And this is where we're going to be like entering the matrix that we need to enter so that we can let the calculator do all that work that I showed you in the last video. So first of all, let's ignore the totals row and column. Ignore them. They're not needed. The calculator will do all of that work for us. How many rows and columns of the data do we have? And what we're talking about is we're talking about the data that we observed, okay? The data we observed or collected. So the answer to that question is that you have 3 rows, that's row 1, row 2, and row 3, and then we have 3 columns, that's column 1, column 2, column 3. If it's not highlighted, it's not part of the data. Now this last row here, or row 4 if you want to look at it that way, this is the sum of the data that we collected, which isn't part of our raw data. And then here on this last column, or column 4, this is our collected, this is our, sum across, column sum, row sum. Those are not considered as the raw data. So maybe we should put the word raw there if you're going to get confused by what the question is asking. So all we're looking for is what is observed in the problem. So the observed data. Okay? So anything we need to do to eliminate this question. So the format for a matrix is then going to be 3 rows by 3 columns. And that's what we're going to type into our calculator. Now, I don't want to write down every single keystroke that you're going to perform on this calculator, so it's best to kind of bring your calculator out and follow along with me. So you clicked your second X inverse key. Now what we have to do is use the right arrow to move to edit. We're going to edit the matrix. Now, I've started this calculator off fresh, so there are no matrices at all typed into this calculator. So I'm going to hit the Enter key, and it's going to ask me for the size of my matrix. Now this matrix is 3 rows by 3 columns. This is pretty nice because it's a square, and that way you can't get your ordering wrong. But the ordering is important. You have to give the correct rows and columns, or else your array of numbers won't be correct. But then what we do is just type in the data. So we type in 96, 133, and if you make mistakes, you can just use the keys on the calculator to fix that, as I've been doing. 61. Okay, so just enter it in and hit enter each time, and that will get you what you want. And you please double, triple, quadruple check that you've entered the matrix incorrectly. So 96, 133, 61. It looks like my second row is fine, and my third row is also fine. Cool. That is going to give us exactly what we need to solve the problem. Now, I want to basically show you what you've done. So if you want to get out of this, some students email me, I can't get out of this screen. So click the second key and the mode key. The second key and the mode key allows you to quit. And now you're outside of the matrix screen. Now, I will show you that you actually did the work. If you click second matrix, check it out. You now have a 3 by 3 matrix typed into the calculator. It's saved there in its RAM, okay? So now, again, click second and mode, get back to a clear screen, and now we're going to let the calculator do the work for us. So let's scroll down. The calculator steps to enter the matrix. Okay, I'll just give you some brief instructions here, because again, there were so many clicks you needed to do. So you went, after you did your second X to the -1 key, you got to move over to edit. And edit was an option setting right there. So you hit the right arrow key twice, or you could have hit the left arrow key once. And then you enter in your data. So you enter the data after entering, sorry about that, after entering the size of the matrix. Okay. So now let's show you how to do the calculators for the chi-square test. This is great because you've been in this menu a ton of times before if you've been following this course, because we're going to use the test menu. Okay, so you stat right, and now you're in the tests menu on the calculator, and you're going to scroll down a bunch of times until you get to the chi-squared test. Okay, now this is not the goodness of fit test. This is the chi-squared test. So I'm going to now go to my calculator here. And actually, what's great about the chi-squared test is that this is on almost all Texas Instruments calculators. So unlike the goodness of fit test, which is on about 90 to 95% of them, this one I'm not worried about. So click the stat button, move over to tests, and then scroll down. It'll take you a little bit. And under my option C, which may be different on your calculator, is the chi-squared test. Okay, so the observed is in A. That's where you typed your matrix. Now the expected is in B. Now remember making that expected matrix on the previous page? Took a long time, didn't it? Well, don't worry about it. Just push your cursor down to calculate, and let's hit enter and see what we get. Well, what we get is the chi-squared value, which was 12.99. Now look on that previous page. That's exactly what we found for our chi-squared test value. After we added up those 9 numbers, it added up to 12.99. How about the p-value? Was that 0.0113 or 1.13%? It was, and this even tells you degrees of freedom. My goodness, this is incredible. So just in the time that it took me to enter that matrix and move over to the test, that entire work was done. Like it's taken me a third of the time to explain all this to you and to actually fully finish one problem. So now what we get to do is the entire hypothesis test with that result. So our null hypothesis is that the number of volunteer hours, keep slipping my pen here, the number of volunteer hours is independent of the type. I shouldn't say type, it was the school educational choice, I think. It was the type independent of educational choice. Because the volunteer got to choose whether they wanted to go to university or community college or not have any kind of post-high school education there. So that is the null hypothesis. The null hypothesis says, oh, they are totally independent. But the alternative is like saying, no, the number of volunteer hours is dependent on educational choice. And maybe the reason why is because maybe the community college or the college has a requirement for community service. We're seeing that actually in a lot of places, including the institution where I work. So perhaps there is some influence there that the educational choice will influence the number of volunteer hours. Okay, so what we're going to do is take a look at that chi-squared test number, which was 12.99. I don't need to type this into the calculator because the calculator has already done me the favor of giving me my p-value, which is 0.0113. My degrees of freedom is 4. That's nice that the calculator just does that. So the conclusion is we have to compare the p-value versus alpha. Since alpha wasn't given in the problem, you always assume 5%, and we can definitely see that the p-value is less than alpha. So since the p-value is less than alpha, we have, my pen keeps slipping today, creating big vertical streaks there. We have sufficient evidence to reject the null hypothesis. So that means that these are definitely not independent. So there is some influence, and we don't actually know what the influence is. I mean, I gave you a possible reason for the influence, but that's by all means not the exact answer. We just know that this is a rare event. We did not get the expected values that we thought we were going to get. So therefore, the volunteer hours is definitely dependent on the educational choice. So this is great, right? I think it's time to do a couple more examples, and we will do 2 more in this video. So get to a nice clear screen and get ready to type in a matrix. But before we go to the next problem, I want to show you something cool on that calculator, right? So remember when we went to stat and went over to tests, and then we went down to the chi-squared test? Notice it said expected was in B, but you'd never typed anything into B. And so I want to now kind of go second mode. I want you to go to second matrix, and notice there's now a 3x3 matrix that you didn't type in. It just magically appeared, but it didn't magically appear. The people who programmed this calculator wanted you to have the 3x3 expected value matrix, because sometimes you want to analyze which cells were way off of the other cells. So if I click on edit and move down with my down arrow key to B and hit enter, check it out. Here are my expected values. And if you think I used this to make sure my answers were right on the previous video, you bet I did. I wasn't going to go through all of that time making that video and not checking my own work here. So there it is. There is your expected value matrix. So just by typing in the observed matrix, the calculator will actually create an expected matrix, which might be useful in case there's some analysis you have to do in your online or face-to-face or paper pencil homework. So pretty sweet, right? And again, all we did is take out the drudgery of all the algebra that by this time you've probably been through and could do so, but why waste our time with that? Okay, so it's time to start the next problem. So in this next problem, it asks, is there a relationship between the two categories in this table? So let me minimize the calculator for a moment and let me take a look here. Okay, so what we're taking a look at is we're looking at some anxiety levels. So we have high anxiety all the way through low anxiety. Okay, this is probably some cool psychological study here. On the left-hand side is we have the need to succeed. So that's high need, medium need, low need. Okay. So I do need to add one more piece of information here. This is probably need to succeed high school or college. So the need to succeed in education. Okay. So people who feel a high need to be successful in education, they have high anxiety, medium to high, medium to low, low. So we're looking at there's this psychological need of succeeding in education, and there's probably a corresponding anxiety level. So we are going to now state that the null hypothesis is that these are totally independent, that they're not related. So the null hypothesis says that and I'm going to start with the column headings here, the anxiety level, okay, that's probably a great way to categorize this. These are all anxiety levels. The anxiety level is independent of the need to succeed. And that need to succeed is in education. And we're talking about a specific person, right? So there's 400 people surveyed here, and they all basically gave their need to succeed in the education and also their anxiety level. So the anxiety level is independent of the need to succeed. All right, now this actually followed what we showed in the previous video of the column category is independent of the row category. All right, so the alternative is like, yeah, okay. The anxiety level is totally dependent on the need to succeed. And I'm sure we've met those high-strung people in our educational lives. Maybe you're one of those people or you know one of those people. But again, knowing one person isn't data. That's an anecdote. And the plural of anecdote isn't data. But we have 400 people surveyed here. So now the next question is the matrix side based on the matrix size based on the data. Now remember, we're only looking at our raw observed data. So what I'm highlighting in yellow is our data. Everything else is a total or a category. So therefore, the matrix size is 3 rows by 5 columns. 3 by 5, okay? So I'm going to type this data into the calculator, and you can see that I'm in matrix B. This is not where I want to be. So I'm going to go second mode. It takes me back to a nice clear screen. Second X inverse. See where it says matrix? Okay. Now I want to edit matrix A. So click over to edit and click enter. Now this is a 3 by 5 matrix. So I'm going to hit 3 enter, 5 enter, and you see that now my data, or actually you can see that right to the right, you see how there's lines right here? This means this matrix goes off the screen. Newer calculators actually have smaller pixels, so you might even be able to see all of this on the same screen at once. Or calculator or phone calculator apps would also allow that too. So now we type in the data, 35, and we go straight across the row, 42, enter. Unlike Excel, this moves to the right instead of moving down. So 53, enter, and see now we're in the 4th column here. 15, enter, 10, enter, 18, enter, 48, enter. See, it just overstrikes the numbers there. 63, enter, 33, 31. Even if your new number is shorter than the number that's in the cell, if you type 4, enter, it just overwrites it. 5, enter, 11, enter, 15, enter, 17, enter. Now I'm going to double, triple, quadruple check that this row is fine, and the row next to it looks good, then the middle row, and then the last two, or the first two rows look really good. I don't want to make any simple mistake in entering these 15 numbers. Now I go to Stat, I move over to Tests, and I take some time to scroll down. You can scroll up as well, you know, so I scroll down to the chi-squared test with the 3 dots. I hit Enter, and everything's set up exactly the way I want it. I put my observed in list A, the expected will be generated in list B, and we don't need to look at that unless the book or homework or I ask you to. And then click on Calculate, and here we have our chi-squared value, which is really high, 48.419. Holy smokes, that is big. All right, so that's 48.419. Now, in terms of degrees of freedom, I know the calculator said it, but the degrees of freedom would be 1 fewer than the row, and then 1 fewer than the column, so we have 8 degrees of freedom, which is what the calculator is going to say. Okay, now by this time, and you see 2 times 4 is 8, there we go. By this time, I really expect everybody in my class to understand exponential notation, so always look for that little letter E off to the side. And this test score is so big, we have an exponentially small number. Now what I'm going to do is I'm going to show you what will get you little to no points on the test, is if you put down the 8 point, let me see, I missed a couple of those decimals there, 8.21. Okay, so if you put down 8.21, you get nothing, because that actually isn't the p-value. If you put down 8.21e with the negative by it, or if you put all the decimals in and then the e with the -8 by it, you're going to get some partial credit, but you're still not, you can't evaluate an exponential number that way. You got to write it as a decimal. So what this means is it's 8.21 times 10 to the -8th power, which means that you're going to have that 821 with the decimal moved 8 spaces to the left. So that means 1, 2, 3, 4, 5, 6, 7 zeros. Because if you move that decimal 1, 2, 3, 4, 5, 6, 7, 8, it'll create 7 decimals. And I have seen teachers say, oh, if you're going to have the negative in the corner here, just put a 0 in front, and that tells you how many zeros you have. Either way, this p-value is crazy small. You witnessed an incredibly rare event, and the conclusion is, because again, no alpha was given, so you gotta assume your alpha is 0.05. Whoa! Is 0.0000008 less than 0.05? I think so. The p-value is less than the alpha, and since the p-value, S-I-N-C-E, I wrote sine. I must have been doing a lot of trigonometry lately. Okay? Since the p-value is less than alpha, we have sufficient evidence, overwhelming evidence, sufficient evidence to reject the null hypothesis, which I hope all of you kind of assumed when you looked at a problem like that. Are people who are, in desperate need or highly focused on that need to succeed, do they have more anxiety when they get the A- instead of the A? Of course they do. Of course they do. So that's me as well. All right. I love getting my A's. So let's now go to the last problem here. Is there a relationship between the two categories in this table? So what we have is, looks like we have got doctors and nurses, and we've got a procedure, right? So we got a brand new procedure. So they've got choices between liking the new procedure, liking the old procedure, because that always worked, and then just like, I don't care, one way or the other's fine. So the first thing we're going to do is figure this out. The looks like this category here, the column category, is whether they prefer or accept a new procedure. So the acceptance of a new medical procedure is independent of doctors and nurses. So it just means that, doctors and nurses, it doesn't matter. It's just that, choosing the new procedure is based on something else. It's not just doctors want new stuff and nurses want old stuff, or nurses want new stuff and doctors want old stuff. Okay, so again, this is just to test this null hypothesis that, hey, it doesn't matter if they're doctors or nurses. The adoption is not dependent on that. But this is the alternative. The acceptance of a new procedure is dependent on doctors and nurses. That's a little and symbol there. So, if we find out that this is true, that it's dependent on the doctors and nurses, and we want to kind of sell a new procedure to the hospital, well, who we're going to invite out to lunch and give the demo, during that beautiful lunch demo, the free lunch demo. Will we inviting all the doctors or all the nurses? Okay, so what's the matrix size based on the data? Now you'll notice that there's no totals on this column or row, which is great because then we just need to focus on this green zone here. This is the raw data of what we observed, okay? So again, you never include the categories or totals, you include just the raw data. And the matrix size here is going to be 2 rows, okay, by 3 columns. 2 rows by 3 columns. So now we're going to go back to our calculator. Looks like it turned off. And now I'm going to go clear, get to a nice clear screen here. Now I'm going to go second matrix, which is second inverse key. See the little word matrix there. And look, check it out. It did create our little 3x5 expected matrix for the last problem, but I don't need it. I'm just going to move over to edit and click enter. Now this one's going to be a 2x3, so I hit 2 enter. And see, I just chopped a row off right there, and then 3 enter. Oh look, it just made it really small, but it still has the data from our last problem, so let's just type over it. So 50 enter, 120 enter, 30 enter. So just type in your data. 100 enter, 80 enter, 20 enter. And I am going to double, triple, quadruple check that the data I entered in is correct, because the calculator is going to do everything in its brain. All right, so let's go now look at stat. Click on stat, move over to tests, and scroll on down, or I'll scroll up in this case, to the chi-squared test. Okay, didn't take as long. So the chi-squared test, this is going to be our test of independence. Our observed is in A. It will spit out the expected in B. We're going to click on calculate, and there we have our chi-squared value, which our test value was pretty high. Look at that, 26.6 repeating. The p-value, oh man, can you try turning that into a decimal for me? It looks like we have another exponential notation. And the degrees of freedom is 2. Now the degrees of freedom is 2 here because it was just basically 1 degree of freedom away from 2 times 1 degree of freedom away from 3, and 1 times 2 is 2. My chi-squared test was 26.6 repeating. Now my p-value was, again, I do not want you writing down 1.6. I do not want you writing down 1.6 e negative 6. I want you to write down the decimal. So to show you one last time in this video, 1.6 e negative 6 is moving the decimal 6 places to the left. So we have a 0.1234516, or the calculator could round that to 2, okay? Or you could, because, that 1.6 could round that to 2. A lot of books state that if you write exponential notation, you move the decimal and round to the nearest first non-zero number. And 1.6 would round to 2, so 2 with 5 zeros in front of it. This is definitely less than alpha, the 0.05, which is equal to the alpha, because no alpha was given in the problem. Blam blam, it's less than, so our conclusion, like the problem above it, is since the p is less than alpha, we have sufficient evidence. To reject. Null hypothesis. Now in the next video, we're going to test for homogeneity. Now someone might feel like, oh no, I've learned so much today. What new is the test of homogeneity going to give me? Well, actually not much, because you've actually done the calculator test you need to do for the test of homogeneity. In fact, you will find that you actually just did a problem for homogeneity if we rephrase the null and alternative hypothesis just a little bit. Well, thank you for watching, and I look forward to finishing up with you the chi-square distribution types, and then we'll do a little summary in one more video after that. Thank you for watching.